Hi, everyone. We'll just wait for a couple of people to join and then we can kick off the session. Just let us know where you are dialing in from today. If you go into the chat, you should be able to switch from hosts and panelists to chat. Otherwise, it will just be myself, Rachel, and Ash that will see your messages, which is very nice, but it'll be very nice to hear from everyone else. I'm going to ask our presenters today, where are you dialing in from? So, Rach, you first.
So I'm in London. So that's where I am today.
Nice. And Ash?
I'm in South Wales, a place called Cwmbran in South Wales, just outside Bristol.
Very nice. Can see we've got some people coming in from New Jersey, Stockholm, Minnesota, Austin, Brazil, Sao Paulo. Wow, very global audience today. So thank you everyone for joining super early in the morning and also very late in your evening as well. We're getting to about 250 odd people now, which is great. So I'm going to switch into our housekeeping. This session is going to be recorded and it's going to be available on YouTube. So if you've got colleagues that you want to send this to, we will be uploading this onto YouTube. It usually takes about a week or so after the event for us to be able to upload it. If you have questions for either Rachel or Ash and you want to ask them at the end, we will have a Q&A section. So please use the Q&A button inside of the Zoom. Finally, please make sure that you switch your chat inside of Zoom to everyone. It defaults to hosts and panelists, which means only we see any of the comments that are coming through. I'll try and respond to some of those things in real time whilst the team are presenting. But obviously, if there's any questions, please put them in the Q&A. And finally, just our code of conduct. Please remember to be kind. We've got a code of conduct. The speakers have put a lot of care and attention into their presentation. I was lucky enough to have a look at it yesterday. So yeah, so it's going to be really good. So just a quick intro. My name is Hugo. I'm a designer advocate at Figma. I've been here for about 2 years. Previously used to work on design systems, so this is a subject that's super close to my heart. Used to work on technical steering groups as well. Have been really interested to hear about both Rachel and Ash's journey at JustEat. And with that, I'm going to hand over to them to present. Thanks very much.
I'm just going to share my screen. So hello, everyone. Thanks for having us here today. I'm Ashley Watson-Nolan, and I'm a principal engineer on the design system team at JustEatTakeaway.com, or JET as we like to refer to ourselves internally. I'm based out of our Bristol office in the UK. I've been working at JET for almost 9 years, first working as a front-end engineer on the JustEat customer website. And for the last few years, I've helped put together what we now call our JustEat, our design system team. I've been helping to rebuild our internal component system, which we'll be talking about a fair bit today.
And I'm Rachel, a senior UI designer working in the same design system team as Ash. Just as a quick FYI, I'm working from a cold, so you might have to whisk me throughout this presentation. But as I said, I'm working in our London office, and I joined JET around 3 years ago now. And I've seen our kind of design system go through a few iterations whilst I've been here. But today we're going to talk you through the evolution of our internal design system and its kind of widespread utilization across loads of diverse teams within JET, as well as some kind of insights into our collaborative processes between designers and engineers and how we work together to optimize our design system.
So for those that don't know, JET is one of the world's leading online food delivery marketplaces. JustEatTakeaway.com is the result of a large merger that went through back in 2020 between JustEat and Takeaway.com. As a result of that merger, JET now operates in 24 countries under various different brand names, such as Skip the Dishes in Canada, Menulog in Australia, and JustEat in a number of our European countries, such as the UK. If you've ever ordered food from us, you'll likely be familiar with one of our consumer applications, but there's a large number of other applications that we maintain across JET as well. These include our restaurant partner applications, logistics and courier applications, right through to more operational platforms used by internal JET employees, such as our customer service agent portal, or our internal experimentation platform, for example, which engineers use for controlling how new features are tested and rolled out. On top of that, we also maintain applications across different technology platforms. For example, on our consumer application, it's available as a website, an iOS application, and an Android application. Like many other organizations, what we didn't want to do was duplicate design and engineering effort across all of these applications and platforms. And that was the main reason that we started building our global design system, Pi, back in 2019. So Pi, which stands for Principles for Interfaces and Experiences, really started as a collaboration between design and engineering to solve the common issues we were seeing across the company at the time. Hopefully, I don't need to sell you on the benefits of the design system, but from our point of view, we wanted to reduce the duplication of effort across our teams and increase the quality of our components across all of our applications. The initial aim of Pi was to align our design foundations such as colors, typography, and space and values across all of our platforms, both web and mobile applications, so that we could have a single source of truth that all teams could use. We did this by setting up a global set of design tokens, which are then gradually rolled out across Jet's design and engineering teams. I say gradually, we're still actually working with some teams today to move them over fully to using these global design tokens. So that's it then, right? Job done, problem solved. Not quite, as I've not mentioned a fairly big problem that we also faced at Jet at the time. So for those paying attention, you may have noticed that Pi existed back in 2019, before the merger of JustEat and Takeaway.com in 2020. And that's because Pi was started at JustEat before the merger of the two companies. But the complexity that merger caused was really the catalyst for where our design system is headed today. When the two companies merged, we went from having one set of applications across our different users to having two sets of those applications. So, for example, on the consumer side, although they were serving different countries, we now had two consumer web applications, one for Just Eat and one for Takeaway.com. The other thing that's also worth mentioning is we also had a growing Canadian business at the time called Skip the Dishes, which we had acquired a few years earlier. And like Takeaway.com, they also had their own set of applications that served their users as well.
So due to the merger, as Ash mentioned, we found ourselves supporting multiple sets of applications. It required us to consolidate requirements from a design perspective to accommodate the diverse needs of the components within our system. All of these updates and new components were brought into our existing Figma structure. It's a fairly standard structure that I'm sure isn't really new to anyone here. I'll take you through how we utilize this structure and why we decided on this approach. So at the core, we have our Pi foundations. It's made up of our tokens such as color, radius, typography, and motion, as well as assets like iconography and illustrations, all used across every team that consumes our design system. Although our core foundations are actually split across several libraries, as we share ownership of our iconography and illustration assets with our Jet brand team. So this allows us to both have control and edit rights without opening up our entire system internally. In the next layer, we've established our two core libraries, one for our light theme components and another for our dark theme counterparts. Previously, we had our light and dark theme components all in a single file. But as our system expanded, we encountered file storage issues in Figma, and it led us to expand and create these themed libraries. The core components served all of our designers and engineers, not just across web, but iOS and Android as well. But most of our components were really platform agnostic. We had a few components in there that had platform-specific variations, including native patterns, although it was quite rare at the time that we were doing this. The last level of our structure was actually what we call local pillars, which Ash talked about earlier. It was a space for individual design teams working on different areas of the business to have their own libraries that supported their unique component requirements. It meant that our core components didn't bloat due to loads of specific pillar requests. We chose this structure because it established clear boundaries and ownership across different levels of the system. The internal design system team owns the first two core levels, whilst the pillar teams manage their own libraries. The setup allowed us to have a solid framework that's proven a really beneficial decision for our team, allowing us to efficiently support our pillars whilst maintaining ownership. But as the design system evolved, we really realized that we could do with making a few updates. The needs of the business were changing. As design system designers, we'd learned a lot, and Figma had come out with some really great updates. All of these things made the design system team realize that we needed to do a bit of rethinking in terms of our structure and the product that we provided. As a company, we really wanted to incorporate more native patterns into our product as well. So web, iOS, and Android. And our core component library structure with our one component suits all kind of method didn't really support this initiative. If we were to move forward housing all of our component kind of variations within one library, we decided it wouldn't be very manageable. It'd be hard to navigate and identify the right components that you needed, and the file storage issue we ran into previously meant that it definitely wasn't a scalable option. So we knew we had to do a bit of kind of thinking and come up with an alternative structure that supported our growing platform requirements, whilst providing a consistent experience for different platform engineers, as well as clarity for our designers when using our libraries. A few months before we started having these conversations, Figma also released some new features, which we knew would definitely enhance our libraries and our users' experience. We could see the benefit to everyone that was connected to the system, from designers, engineers, and also ourselves as designers who provide Pi. The updates from Figma we were really interested in were the new variables concept that would allow us to manage our Figma tokens in a smarter way, as well as the new component properties that were released, and we knew it meant we could build more efficient components. But at the time, we weren't really in a position to actively implement these, as we knew it was going to be a really big piece of work and it would have a really big impact on the design system. So we held off, and luckily with the platform initiative, everything came together quite nicely. So we decided the best option was to create a new structure that would support the growing needs of the business, and then at the same time take the opportunity to embed the new updates and release a new version, Pi 3, a newly improved version of our design system in Figma. So what we decided to do was split our core components into making a web and an apps division. It was the best solution for us. We did decide and contemplate allowing iOS and Android to have their own libraries, but we decided it would cause a lot of duplication and it really increased the complexity when designing specifically for apps. So most of our components still in the apps library are still shared between iOS and Android, as we're still currently in the process of auditing everything. But where we do have native patterns, we have platform prefixes that we just add to naming conventions for the components, like both designers and engineers to easily identify what platform things belong to. But as I mentioned, we also took the opportunity to embed new Figma properties and features into the components that we were rebuilding in the library. So I'm just going to take you through what we implemented in a couple of different examples. So firstly, Booleans meant we could drastically reduce the quantity of the component variations that we needed. And it was also a really big impact into the way that we built components as well. It required a slightly different mindset, but has been really beneficial to the team. Next, we have the instance swap prop. As part of our brand identity, we utilize a lot of icons and illustrations within our components. This feature has allowed our pillar designers to easily replace assets. Another use we found is actually embedding slots into our components, allowing custom content to be easily added into our container components with no need to detach the component. The new text prop, again, is another great feature that's just increased the usability of our components, allowing designers to easily override content and quickly get designs updated. Then lastly, for us, was nested components. Exploring this feature was quite interesting, determining to what extent we wanted to use this and what nested component properties we wanted to expose. Currently, we've still erred on the side of caution by only exposing properties that designers can freely modify. Because at the moment, the functionality to expose singular properties within a nested component isn't available, but it's something we'd really like to see in the future. But another really big update that we did was the overall of updating all our tokens to use the new Figma variable system. So this has allowed us to store both our global and alias tokens all together in a single source of truth. And as you may have spotted in the new structure, we're actually able to remove the theming duplication that we had. And all this was possible through this new feature, as we could actually embed themes at the token level instead of the component level. So it's meant that designs could be like really seamlessly swapped between themes now, which is great. Another great update was that Figma actually introduced radius and spacing variables, which we didn't have before. The amount of time that we'd had comments from engineers being like, okay, what token is 8 pixels again, would actually surprise you. So now having these embedded within our components means that engineers can now access the full variable names through dev mode, which is something we've had really great feedback on.
Now, Rachel just mentioned our Pi design tokens, and from a development side, we first set up our token solution back in early 2020 as our first step to align some of our design configuration across web applications, iOS and Android apps. Our token repo came about through a number of our designers and engineers wanting to reduce the duplication of effort when communicating what should be relatively straightforward changes, but become much bigger in terms of effort due to the number of times we are having to communicate that change out across our teams. As shown earlier, small changes like this really don't scale well across a company like ours, as we have such a large number of web and native applications being maintained by different teams. So what we did back then was to store our design tokens in a JSON C file, which is just a JSON object, but the C stands for comments, which allowed us to document our tokens in line in this JSON file. We then wrote a fairly simple compilation step to output these tokens as SAS variables, which our web projects would use, and JSON, which our apps consumed and compiled in Swift and XML. We later added compilation to native CSS variables to give web projects more flexibility over which solution they wanted to use. Now, our design tokens were one of the things that existed in Pi before the JustEat and Takeaway.com merger. And after the merger, our application landscape looked a lot like this. So there was a customer platform for JustEat, Takeaway.com, and Skip the Dishes. And this was repeated across all of our pillars for our 3 different brand platforms. Now, if that prospect wasn't enough to deal with, because we're working in front-end development, not everyone built their applications using the same frameworks. So JustEat was building the majority of their web applications using Vue.js. Skip the Dishes were building their applications using React, and Takeaway.com were using a bit of a mix of either React or Vue.js across their different applications. And the silver lining to all of this was that across all of these different applications, there was a really good level of understanding of what a design system was and the benefits of using one. In fact, across these applications, most of those teams had been building their own component systems on a much more local level, some built in React, some built in Vue.js. So for example, the Takeaway.com consumer team had built a React component system that was being used by all the teams working on the Takeaway.com consumer website. Similarly, at JustEat, there was a Vue.js component system, which was shared across a number of the JustEat web applications. And similar component systems actually existed across many of our application teams, all of them trying to solve pretty much the same thing: to reduce duplication of commonly used UI components like buttons, notifications, text inputs, so their teams weren't creating these components over and over again. Now, this image best illustrates what at the time my brain was putting together to visualize the current state of our design and component systems across Jet. So we had Pi, our design language, which had been updated with the new Jet branding after the merger in 2020, and our design tokens, which allowed teams to share common design foundations like colors and font sizes. So from an overall design perspective, we had a pretty good structure in place. On the website, we didn't have a clear plan of how we could simplify all of the different component systems across our organization, so we could reduce the amount of engineering duplication that was happening. So to try and address this, back in 2022, I started to pull together senior engineers from across the organization to try to do just that. At the start of those conversations, we were discussing if we could at least combine what we had into just one React and one Vue.js component system, so that at least we didn't have multiple component systems at a framework level. But even this seemed like it could still be quite a difficult challenge. I'm not exactly sure when it was suggested, but during one of the meetings we had discussing potential solutions, an engineer from one of our application teams said, "What about web components?" And that question sparked the start of the discussions that turned into us building out a web component proof of concept. And before we go into the process of how we created these components, it's probably worth taking a quick step back to explain a bit more about web components as a technology. So what is web components? There's essentially a set of web platform APIs allowing you to create reusable, custom encapsulated elements. Quite simply, think of it as, what if anyone could make their own custom HTML elements? That's essentially what web components allows you to do. So web components is made up of 3 main technologies: custom elements, shadow DOM, and HTML templates. So what do each of these do? As its name might suggest, custom elements is the part of web components that lets you define new HTML tags or extend existing ones using something called the custom element registry. So for example, it lets you write markup like this. So you can see here that I've got my own custom HTML tag for my awesome modal component. And with a little bit of JavaScript added on top of this, the browser will know that whenever it sees this tag, that I want to render my custom modal web component. The second technology that makes up web components is called shadow DOM, and it's definitely one of the coolest sounding browser specifications out there. Shadow DOM is the part of web components that handles encapsulation, essentially keeping your custom elements features private. So one of the great things Shadow DOM gives your web components is style scoping, so that styles defined within your component apply only inside that Shadow DOM and don't leak out to the rest of your web page. So if I wanted to write some CSS inside of my custom modal component that gave the buttons inside my modal a background of blue and a text color of white, those styles would only apply within that custom web component. They wouldn't make all of the buttons on that page those colors. Finally, the third web component technology is called HTML templates and covers 2 elements: template and slot. Templates useful for sections of markup that you want to reuse multiple times on a page, and slots, meanwhile, will likely be familiar to anyone who's used a lot of other UI frameworks like React or Vue, as they work in a very similar way in web components too. Web component slots let you define a section within your component that you can then fill with your own markup when using the component. So for example, the modal component I showed earlier, instead of having a header already defined, could simply have a slot like this one shown, so that the content of the modal can be passed into the component when it's being used. Now, there's a lot more technical detail that I could go into in terms of web components, but probably the most important thing to cover today is why were they a good solution for us at Jet? There are quite a few reasons, but I think the two most important benefits are how interoperable web components are and how future-proof they are. The importance of interoperability is something that I touched on earlier when describing the design system situation at Jet. So if we look back at that, where we have React and Vue being used across our organization by different teams, web components opens up a way of us being able to share these components across the applications. So we're not duplicating engineering effort unnecessarily. And this leads straight into the second major benefit, which is if you write your component system using web components, it future-proofs your project in multiple ways. Firstly, it means you're future-proofed against potential project migrations. This could be a migration caused by your team choosing to move from one JavaScript framework to another, or for a team wanting to move away from a framework entirely. For example, we have teams at Jet who are looking to simplify their stack as they need extremely performant, secure pages. So being able to offer them a set of shared components they can use with vanilla JavaScript opens up a lot of potential for those teams. Secondly, it future-proofs you in terms of standardization. When you write components using a framework, you're always at the mercy of the framework release cycle. For example, it could be that your favorite framework decides to do a complete API rewrite with their next major version release. That's got the knock-on effect of meaning that you then have to update your components to work in that new framework version. If you're supporting multiple teams, you then also have to help manage that migration. And this is difficult because as a design system team, we can't really control the timeline for teams migrating to new versions of the framework. If you're writing your components in web components, however, it's much more straightforward to take those components from one version of the framework to another. So that's really the reason why we started building out a proof of concept for web components at the start of last year. We saw it as a way of us being able to truly unify our design system across our web platforms. So what we wanted to do now is take you through the process we've used from design right through to development of our components, and some of the things we've learned along the way that has led to us adapting our ways of working. It's important to note that we'll talk about this in quite a linear, happy pathway, but in reality, there's a lot of discussions and back and forth between designers and engineers throughout this process, and we'll cover some of the more interesting of those discussions later in the talk. And before we could start work on any components, the first thing we needed to look at was prioritization. Which components would be the most useful to build first? Now, I mentioned that we started off our web component project as a proof of concept, so with that in mind, we looked to build two components at the start. One simple component and one complex component. So for our simple component, we chose to build a button, and for our more complex component, we chose a modal. Once we decided that web components were a viable technology for us to continue using, we made a list of all of our components being used across our various web component systems, so across the JustEat, Takeaway, and Skip teams. Then we looked to filter down that list of components based on whether we thought that it was truly a core component in our design system. So was the component generic enough to be used across a number of our applications? Once we'd done that, we then looked to put them in order of priority based on how often they were used. So by designers, by looking at Figma instances, and by developers, by looking at the number of times that those components were being used in our code bases. And then finally, we rejigged that list a little based on the complexity of the component. Complexity was an important thing to consider because what we didn't want to do from an internal perspective was to spend a year working away on this and only have 3 components to show for it. We knew that the first 2 components would likely take a bit of time for us to put together, as we're also putting a lot of the building blocks together for the system at that stage. So prioritizing some less complex components after that made sense, so we had more to show in terms of our progress. So the result of that process was this extremely fancy spreadsheet. And this is something that we still use now as we continue to build out our components. It's not the flashiest part of our design system, but it does exactly what we need it to do, which is tell us what component we should be designing or building next.
So let's start with the audit process. So the aim of the audit was just to gain a really thorough understanding of the current usage of the component. It involved assessing how it was currently being used, identifying instances where designers or engineers may have encountered issues and for what reason. But it was also a really great opportunity to look at best practices. So we gathered information through a variety of different methods. Firstly, we used Figma's library analytics feature to assess current usage. Noting that here we were mainly pulling analytics from the previous version of Pi, whilst we were increasing adoption of the new version Pi 3. We also turned to our internal design system team to gather feedback, both from designers and engineers as well. Every day we work with these components and the teams that use them, so we were definitely bound to have our own opinions and suggestions as well. We also looked externally, taking the opportunity to explore standards and best practices, because not all design systems supply identical components with identical requirements as well. External exploration is a really valuable tool to validate your design decisions and assumptions. A website called Component Gallery is a really great repository for components across loads of different design systems. So I would definitely check that out when you're doing this work. But once we gathered enough information to really start making them decisions, we then took this back to our users through quick one-to-one, 1 minute like Slack polls or questionnaires, more detailed feedback. Because we support so many different teams with really varied requirements, validation really was key to ensure that we create components that are actually useful and people want. So once we'd gone through the audit process, we knew, we had a really good understanding of the requirements moving forward. We then moved on to creating our design deliverables. I'm sure for each design system that looked really different, and everyone has a different definition of done. But I'm going to show you what that looked like for our complex MVP modal and what our design team's definition of done for any component work is that we're doing. So for us, a component is ready to hand over when, and it may be obvious, but you have a finalized component that includes all the requirements that came from the audit process. It's important for our variants to be streamlined and well organized. This means eliminating any unnecessary layers to reduce complexity. Additionally, variants should be easily understood within the page, and component properties arranged in an order that enhances the efficiency for our users. Keep things simple. Accompanying each component variation is the documentation as well. So we standardize this using a really convenient template to ensure consistency and just really help streamline that process. We want the documentation to facilitate a smooth handover with our engineers, but also additionally facilitate and just reduce that, or kind of help increase knowledge amongst our users and reduce our role as a knowledge bottleneck. Currently, the documentation lives in Figma, but this kind of is a temporary solution whilst we work on integrating it within our documentation site. Versioning, as you see here, is something we've recently added to our definition of done on the design side as well. As the kind of system has grown, each component now has its own individual version number, which follows the semantic format. We make sure that the version number is highlighted across loads of different touch points, and this kind of all ties together with our changelog. But the final step here, before we mark anything as done, is a thorough review. So we use the Figma review functionality to send out requests, just so we can provide another layer of kind of stress testing, proofreading, and generally making sure that everything looks okay.
One feature our engineers use a lot during the design audit and handover stages is the commenting functionality in Figma. And something I personally find really useful is the Figma for VS Code extension. As you can see in this video, it lets you view all of your Figma designs side by side with your code. And you can also leave comments and see replies all without leaving the editor, which I personally find pretty helpful as it stops that context shift you can get from moving between apps. So using comments in Figma helps our designers and developers interact a lot more asynchronously as the components being designed and built. And it helps us to spot things that we may need to document as well for our design system consumers. Once we are happy that the component is ready for development, we then get to my absolute favorite part of our component process, which is creating Jira tickets. Hopefully you can tell that's sarcasm, but even though it's not my favorite part of building out a component, it does play a really key role in our development process. It ensures that all of the design system team gets visibility of the work to be done and can feed into that work as it's getting prioritized. For each component that we build, we nominate someone to be what we call an epic champion for that component. And the role of an epic champion isn't to do all of the design or the development for that. Their role is ultimately around ownership of the component. So making sure that we're scoping and prioritizing the work to be done and coordinating any conversations that need to happen between design and development to ensure that progress doesn't get blocked. It's a really important part of how we build components and also a great way of sharing ownership of the design system throughout our team, as we encourage all of our designers and engineers to champion epics in this way, no matter their level of experience. As you can see from this flowchart, component work goes through a few stages before someone actually starts doing any coding. The Epic champion will write up the Jira tickets for that component. Those tickets will then get put through what we call refinement, which we make space for each day after our team's stand-ups. Refinement is just a time where other designers and developers can review the proposed tickets and make sure the relevant information and right amount of detail is included in those tickets ready for when someone picks that work up. As a team, we use Kanban, so once tickets have been refined, they will then get prioritized each week for developers to pick up and start working on. The next part of our flow is the most fun part from a development perspective, and that's because it's where we do the majority of the actual component development. So to give a brief overview of our tech setup from a web perspective, we write all of our component code on public GitHub, which anyone can view on our Pi monorepo. We'll share the link to this and other design system resources after our talk as well, so don't worry too much about trying to note it down. Monorepos are now fairly standard for this kind of component library, and a monorepo essentially means that you have multiple NPM packages inside the same GitHub repo. I'll talk more about how we version and package up our components in just a minute, and how we handle that within our CI workflow. In terms of code in our components, we use a web component library called Lit, which provides a nicer developer experience when writing web components, so you can keep your own code a lot more succinct and declarative. We've been lucky enough to work quite closely with the Lit team over at Google while we've been building out our component system. And they're not only extremely knowledgeable about all things web components, but they're really nice people too. So if you want any help with Lit or web components in general, I'd recommend checking out their Discord channel. Like most design systems, we use Storybook as a core way of developing and showcasing our components, using Storybook controls to enable consumers of our components to easily see and play around with all of the various states and options included in our components. Amazingly, the Storybook team released a version that supported native web components just a few months before we started our own POC. For anyone who's used Storybook when building out React or Vue components, it feels almost exactly the same. We also use Storybook plugins to help with testing accessibility and for giving direct access to Figma designs for those of access as well, again helping us when we want to compare the built components to our design files. As part of development, we also ensure we've added the component to our Pi documentation site, pi.design, which is what we use to document how to use our components to consumers of the design system. Once the component's been developed, we add a code section for that component to the doc site, which effectively acts like an interactive README. We're using Storybook embeds to show the component states and provide a kind of interactive playground for component props, ensuring that they make use of the full interactivity that Storybook gives us alongside our documentation. Our doc site is all publicly available, so if you do want to check it out, just go to pi.design and take a look around. Now, we've broken QA down into a separate step on these slides, but really testing is built into the core of how we develop our components. One of the areas that we put quite a lot of work into as part of our web component POC was our test and release process. That's because we wanted to ensure that we built good foundations for the components from the start. It's much easier to change things in a monorepo when you only have one or two component packages than it is when you have lots more components sharing that configuration. So we use Playwright for our component and accessibility tests, as well as Percy for visual regression testing. For a design system like ours, it's hard to underestimate the importance of visual regression tests. They're extremely useful for even the smallest update, but especially when testing the rollout of design token updates that can affect a large number of our components. The other side of our testing is how we test our components for use from a consumer perspective. And what you can see here is a video of our external test repo, Pi Aperture. Because one of the core requirements for our web components is for them to work in React and Vue applications, we like to ensure that we test our components in frameworks such as Next.js and Nuxt as much as we can. So while we use Storybook for bootstrapping our components and displaying their different states and props, we've also built this way of testing our components that replicates how our consumers will be using our components too. This is probably the area of our testing that's changed the most over the last year, as we've initially tried to build these example applications inside the same monorepo as our components, but we found that by doing that, it was hard to guarantee that the applications were completely separate from our component config, and our early adopters were finding bugs that weren't being replicated in our applications because of this. So we eventually separated out the test applications into a separate repository instead.
After the engineers were all done, it was time for the designers to get their hands back on the component. We just needed to ensure that the component looked and functioned as it was intended. It's basically one big stress test. There was a slight learning curve when it came to inspecting web components initially because of this shadow DOM that Ash mentioned before. So it was really great to work with the engineers just to understand the differences and how we needed to adjust when QAing components. Once again, we relied on a rather fancy spreadsheet. We found it way more convenient to consolidate issues all in one place linked to a single Jira ticket, as tackling issues through separate Jira tickets just didn't really give us the complete picture that we needed. We're also currently in the process of creating a designer's QA guide that will hopefully benefit both design and engineering, ensuring that we're consistent with our QA process no matter who picks up the task, but also giving engineers insight into our process and hopefully decreasing issues as we open transparency towards the end goal.
The final step is actually releasing our component. So we use Semver for our package versioning, and as with our testing process, we did a lot of upfront foundational work on how we coordinate our releases. Our monorepo uses GitHub Actions for all our CI workflows. We use a tool called change sets to automatically tag and version our components. This allows our developers to focus on the type of change that they are making, such as a major or a minor change. And then change sets handles actually bump in the package versions and group in changes from multiple PRs together into a single version package release. Our components are currently released as individual components. We're also currently looking at whether we can provide our web components as a bundle for consumers while still enabling them to tree shake out the components that they aren't using.
So our team's been working on this process for almost kind of 18 months now. And in that time, we've definitely learned a few things, not just about how our designers and engineers work together, but also how our design system team works with those using the system. One of the things we've learned from our designers and engineers working so closely is that discussions will always crop up once development work starts on a component, no matter how hard we try to anticipate and address all these scenarios beforehand. This is why fostering a close relationship between your designers and engineers is so crucial. If we worked in a more waterfall way where designers and engineers didn't have much communication, discussing and resolving issues that crop up would really block the development process. So what sort of issues do you want? Let's take a look at a couple of examples that we came across. A really good one came when we were looking at our text input and we started exploring the different input formats across the kind of Jet business. If we look at it from a design perspective only, it's easy enough just to support any format that we want, from dates to card numbers. Just change the text, simple as that. But when we started having conversations with our engineers, it was clear it just wouldn't be that easy. Including all possible input formats would add a high level of complexity to the component, as well as potentially increasing the download size. So we had to decide whether we should support this. Eventually, we decided that we should provide a base component with a minimal set of inputs on the left, whilst allowing engineers in pillar teams to extend this base component with new variations when required later. It was a great example of kind of just understanding the different constraints across our platforms and really the need to collaborate. So we could really work closely to ensure we had alignment when both delivering our products.
The second example is still a pretty contentious discussion to this day in our team, and that's the relationship between buttons and links. So on the surface of things, buttons and links are pretty straightforward components. But where things start to get a bit more tricky is in the semantics of how they're often used on web pages. So here are a couple of scenarios that we currently have on our sites. The example on the left shows what visually looks like a button, but semantically, as a HTML tag, it needs to be a link because it navigates to a new page. And the example on the right shows how we display our allergen info on our menu page. So this visually looks like a link, but if you click on it, it opens up a modal. And so semantically, in web development terms, it needs to be a button. So from a development perspective, you effectively have two components that visually look one way, but may need to act differently due to how they're being used in context in a design. Now, there are multiple different ways of solving a problem like this. Some in our team would love to try and outlaw buttons being used as links by designers, but in reality, that's almost impossible for us to enforce across all of our teams, and would likely just lead to those teams working around our components instead. So we developed a way to allow consumers to switch out the HTML tag when needed. And if you want to see more detail on this and the discussion itself, you can take a look at our GitHub discussion, which is linked at the top here. The main point really that comes out of an issue like this is that sometimes the semantics of code can make a seemingly simple component a bit more complex. And when that happens, it's important to work together as a team to come to a solution that ultimately helps consumers of your components.
Another really big thing we learned when tackling various challenges is that knowledge bottlenecks can really become apparent over time. We talked about our epic champions before and the benefit that this had on the process, but we ran into situations where the epic champion was away and suddenly we were without information. So to help this, we really made it priority not to silo work, both for designers and engineers, ensuring the work wasn't solely being done just by the epic champion, which was a really easy trap to fall into. Additionally, we tried to increase team visibility, both through demo sessions for engineers and design critiques, just to really make sure that everyone was in the loop.
One area we've adapted a fair bit over time is our token processes. So when we first rolled out our design tokens, it was mostly being used by our consumer teams. So we didn't have to worry too much about changes that we made to the structure and the naming. However, as the tokens got more widely adopted across Jet, we had to start thinking about the impacts of these changes on other teams. Even a small token name change would be a break-in change for our consumers. So to help with these updates, we've made two main changes. The first thing that we did was to put in place what we call our design token committee. This is made up of representatives across design, web, and apps, with meetups happening every fortnight. And we use this group as a place to discuss all the potential changes we want to make to our tokens, so we can get input from all of our key stakeholders. The second thing that we've done is changed how we roll out break-in changes to our tokens. And this now we follow a release cycle similar to what you might see from a language like Node.js. We now limit ourselves to 2 major version releases every year. So any break-in changes get grouped into a beta version of our token package, and then that gets moved to a stable release every 6 months. This allows teams ample time to plan for these upgrades, or try out the beta release early if they want to, as well as giving our consumers a guarantee that they won't get hit by break-in changes any more frequently than this. The final thing that we wanted to share was around adoption and how we communicate with our design system consumers. First thing to say about this is that adoption is hard. That being said, getting the ball rolling is always the hardest bit. And what we found is that finding people passionate for what you're working towards is really important. They usually become the earliest adopters of your system and can then potentially become advocates for what you're doing when talking to other people in the company. This ties into an initiative that we started recently, which has been putting together a group called Pi Advocates. And this is really about working closely with designers and developers in other pillar teams across Jet who are passionate about using and improving the design system. Another important thing to consider about adoption is to ensure that whatever you're trying to get people to adopt has more value than the previous solution that they're using. And that's the strategy we're really using for the Pi 3 Figma library, and it's something we're trying to achieve building out the Pi web components as well. A great example of how communication can help aid adoption was in a recent project that our team helped with. So as a business, we were required to standardize the UI of our cookie banner across all of our web applications. As our web component project has been gaining adoption over the last 6 months, we were pulled into discussions for creating a web component that could achieve this in a way that would work across React and Vue platforms. The benefit to us as a design system team in helping build this is that if applications start using this new component, they'll be already set up to use all of our other web components as well. So it's actually provided a really good foot in the door for our new component system, helping to sell teams on the benefits of using these components moving forward. And it should help us with integration going forward then. One of the other main ways we communicate with our consumers is through our Help Design System Slack channel. We use this channel for all design system help requests and have set up Slack workflows so that each request gathers enough information for someone in our team to be able to help. Members of our team alternate responsibility for helping with these requests, and each request gets tracked by our team to ensure that we've resolved people's help requests. The system's worked really well for us and is still an area we'd love to improve further with better automation when requests come in, but it's really helped to give a clear place for consumers to contact our team when they need help with something.
So we just want to say a really big thanks for joining and listening to our journey towards our global design system. Looking ahead, we've still got a lot of things to do, including many more web components to build and really increasing our adoption as well. But you can keep up with our progress through any of our socials or our documentation site linked at the bottom. I think we have probably got time for some questions as well. So I'll hand back over to Hugo.
Thanks very much. That was incredible. And like some really great stuff going on in the chat. I'm going to try and share my screen over now. So hopefully you can see the Q&A slides. We've got a ton of questions that have come through. But my first question is going to be, do the Pi advocates get free Pi for their inclusion in that program? Please tell me yes.
That would be nice. They do get stickers. No Pi currently, but you do get a very nice sticker.
Nice. Nice. Right. On to some slightly more sensible questions. We've got one here from Luis Antonelli asking about accessibility. So how do you apply and think about accessibility in your design system?
So from a design perspective, we have some really great accessibility people within our company that even we really utilize, which is a really great asset to have. But we really like to just keep things as simple as possible, because everyone's role on the design side to like advocate for accessibility doesn't just come from the design system team. So we're totally here to help. And obviously everything that we provide on the Figma library, we have accessibility standards for, and we're in charge of our stuff. And yeah, we're here to just really like help and support. But in our company, it's definitely everyone's role, not just the design system teams.
Nice.
Yeah, it's the
so
same.
it becomes this. Oh, sorry. Go for it, Ash.
I say it's pretty similar on the engineering side, really. The main thing for accessibility is probably one of the main reasons that we had a design system team set up anyway, because the classic thing in engineering is consumer platforms always get a lot more of the time and the engineering effort. But internal, the experimentation platform that I mentioned before, the big selling point is getting our components that are fully accessible into those sort of platforms, making sure they're fully accessible, because they don't tend to have the time to spend on accessibility that we do for our external customers. So that's one of the big things that we do. We actually just hired a lead accessibility expert as well, actually, she's going to be working with us going forward as well, which is absolutely awesome. It's like starting to be even more recognized through the work that we're doing in the design system, which is great.
And is that role going to sit inside of the design system team, or is it going to sit external? So it's also helping the pillar teams as well as core.
Yeah, it sits external, so it sits across all teams. But yeah, they'll be working with it.
Because obviously there's, as we all know with accessibility, it's not just down to what's happening at that more granular level, but more broadly the user experience across that journey too. So yeah, makes complete sense. We have another question here from one of our previous speaker from a previous live stream, from Jokbas, who is an engineer on the Kayak team, who asked, how do you ensure consistency of naming, be it component name or prop names, between design specs and implementation? Is this even up for consideration?
That is a really good question. So we actually had an initiative last year where we realized that we were really diverting, especially in like component names, especially because everyone has like just different standards for what they call stuff. You even see it just, design system, nothing is named correctly. So we actually did like a really big like audit across the board. This actually happened before we had the split of like web and apps on the design side. So it made it a little bit more complicated, especially like web apps. Things are very different naming convention wise. So actually us having that split has made things a lot easier. So where we have like dialogues, for example, on apps, that's what we call our component in the design side, is a dialogue to match that on engineering. So that has made things definitely a lot easier for us, just for consistency reasons. I don't believe we have a one-to-one for props, though. I think that is where we slightly differ, just because of our users, the way that people like utilize a design component versus an engineer using their component. Like they're going to like naturally look for something slightly different. Where we can, we 100% have consistency. But for smaller things that feel just a little bit more intuitive, what's best for our users is what we naturally move towards.
Yeah, that makes sense. Ash, anything to add on the engineering side for that?
No, I think it's probably one of the benefits of using design systems that we've seen, though, is that it does, because of the compilation step we have from the JSON-C, that gets automatically output into variables for web and for apps. So our naming across all of those systems now is the same, which is great. So when we do refer to a certain color or an alias token, you can usually, it's not so far away usually, that if there is a tiny difference, it's usually very close. So you know exactly what it's going to be. So.
Yeah, prop mapping is an interesting challenge, and there's different schools of thought about the approach for it, because there's the way that the kind of schema of a component inside of Figma doesn't always necessarily lend itself to naturally being an exact one-to-one with what you would replace with in code. It's one of those things where often I think about it when I've been working on systems, more of being able to help to anticipate the nature of the change and how that conversation kind of evolves through that process. So yeah, I'm going to go to the next question here from Robert, who asked, this is a quick one, how many people are full-time working on the design system?
It's a good question. Because our team does change pretty close. But I think it's in terms of full time. So on the web side, In terms of our design system team, I think when we last met up, there were like just over 30 of us, and that includes product, delivery, designers, mobile engineers, and web. We are like we're growing our mobile team and design systems at the moment, for example, because of the same reason we had on web, where we used to have a core team. We still have a core team on the app side, but we used to have to try and get time within the core team to do design system stuff. So rather than do that, we've now got design system allocated engineers in our team that do that and work with the core teams, and we're growing that space as well. So we have 2 senior engineers, one on the iOS, one on the Android side, and we just hired a junior on the iOS side literally yesterday. So that's has grown as well. On the website, I can't remember, it's probably about like 10 engineers I think we have on the website.
And then we've got 5 designers, and then we throw in a couple of PMs as well.
Amazing. So yeah, I think one of the questions that often comes out in those conversations is, was it at a particular point that you got someone who was a senior stakeholder within your organization to be the champion to help push for increasing the headcount within the team? Or is that just something that's naturally appeared between design and engineering orgs just based on feedback? I don't know if you can speak at all to that process. It's just, I think that's a challenge that a lot of teams face, is like the design feeling a bit of fatigue if you're like the only person that's responsible for the design system when you've only got 2 people working on it. It's just one designer, one engineer. So I don't know if either of you can speak a little bit to how that evolution of the growth has happened.
Yeah, definitely can from the engineering side. So on the engineering side, we used to be like do a lot of the design system work in our like what we called our core teams, which were again mostly consumer based, and a lot of it was like anything in big organizations is like proving out the worth of it, and eventually hopefully you get your stakeholders that buy into it. We got quite lucky with it. That's one of the areas we got quite lucky in the merger, is that, so I was previously on the JustEat side, the Takeaway.com side already had a design system team in their customer platform. And so when we merged, about a year later, that's when we decided to form one kind of bigger design system team. And that's when we pulled in designers who, again, the designers used to work across a bit more externally, but that's when we pulled Rachel and other designers into our design system team, which has been like absolutely awesome, to be honest. It's been really good to have those designers in the design system team.
And anything to add, Rachel, in terms of like how that's evolved from a design standpoint?
Yeah, as I said, we definitely absorbed a couple of people from the merger, which has been really great. And just so I really emphasize, I do think we have really good like stakeholder input at Jet. And I do think we're quite lucky from that standpoint to actually have like senior people in the company actually be aware of what a design system is and what we're actually doing is actually really nice. And we're also really lucky to have like PMs directly within the team as well that help advocate for us. So it's not down to seniors to do that job. We have people embedded that are like out there doing that work as well, which is really nice.
So you're, even if people aren't explicitly called champions, you're just naturally, it's proliferating throughout the organization that people are thinking, oh, wow, that's great. I'm just going to quickly raise a poll in the chat, and we're going to go to our last question before we finish up today. So thank you everyone so much for submitting your questions today. Sorry we haven't had time to ask them all. But the final question from an anonymous attendee is, when it comes to doing wireframes versus design, has your team created any library for the wireframes versus the design? Is that something that's a helpful approach for the team, or is it just all using the components?
So it isn't something that we provide, purely because from our perspective, having a design system within a Figma library kind of breaches a lot of that work and the necessity to have a wireframe. So at a base level, if a component isn't entirely doing what you need it to, at least you've got like a base. You don't need to completely design them from scratch. So it's saving you a lot of time anyway. So it's not something we as a company or as like a design team have really found a massive benefit for. Of course, like old school pen and paper still exists within our company. Wireframing definitely does happen, but it's slightly more of a one-off rather than everything started from scratch. So it's not something we currently support.
Yeah, it's one of those things where it depends how much the evolution of the design is going to, having the pre-built design is going to be a distraction or not. Sometimes we see people have a mode set inside of their collection specifically to strip out all of those values and take a white label approach. But you're right. Like, I think when it's to do with the general composition of those things, by and large, the need for wireframes is probably a lot more limited. Cool. All right. I'm going to go over to the final slides. Just a quick call out. We have our conference config happening on the 26th and 27th of June. If you scan the QR code or go to this short URL here at the bottom, you can sign up to either come in person or virtually. We'd love to see you there in person, but if you aren't able to travel, then there should be some great opportunity to connect with us on that. And that's everything. Thank you so much, both Rachel and Ash, for that great talk. I think there was loads of stuff for people to take away, and really appreciate the in-depth knowledge that you shared with everyone. As I said, we will post this up on YouTube in about a week or so's time. So if you didn't manage to catch the start, then you should be able to finish then. So with that, thank you both very much. And yeah, enjoy the rest of your day. Thanks.
Thanks.